Okay, starting chapter 8. This will be graphing. We're just going to start with the first term. F of x is equal to ax squared of our quadratics. So let's get started. Um, First thing, identifying some characteristics of quadratic functions. So when we're talking about our quadratic functions, right, we were used to seeing these as our polynomials, ax squared plus bx plus c. It's nonlinear. Standard form is our standard trinomial. A is not equal to 0. It's a U-shaped graph. It's called a parabola. And we're going to start graphing them where B and C are both equal to 0. So we're just going to have that first term. So here's kind of like the first characteristics, and it's a lot. Hopefully you'll remember we're going to be comparing things to parent functions. So in this case, when we're talking about the parent quadratic function, f of x is equal to x squared. And that's pretty much modeled by this U-shaped parabola right here. So there's a couple different things with this. It says the graphs of all other quadratic functions are transformations of this graph. So we could take this and we could do all kinds of things, right? All the transformations. We can slide it up or down. That would be a translation. We could reflect it. We've seen reflections before. Rotations, it could be turned on its side, different things like that. We're pretty much going to be sticking with a lot of the basics. We're not going to do too many transformations this year. So when we're looking at a parabola, the lowest point when it opens up or the highest point when it opens down is called the vertex. So you can see that is pointed right here. It's at the origin on this parabola. So the vertex of the parent function is 0, 0. The vertical line that divides it, we have an axis of symmetry. It will go through the vertex, okay? So in this case, our axis of symmetry is the y-axis, or it can be described in terms of the vertical line, x is equal to 0. So we'll be describing it kind of in terms of what is the x-coordinate there, and that would be telling us the answer. The other thing we're going to look at is whether it's increasing or decreasing. Now, typically we read graphs left to right. When we're reading left to right, x is always increasing. So you remember you have two different things happening. You're going to always have the characteristic of the x coordinate and the characteristic of the y coordinate. So if you're looking, less than 0 as x is increasing, y is decreasing, okay? And then greater than 0, when x is greater than 0, as x is increasing, y is increasing. So we're just going to be describing those kinds of information. And I believe this is on page 247, all of this, so you don't have to write it down. You'll have it in your book. Okay, so looking at an example from the textbook, so you can kind of see how the textbook describes it. It says, consider the graph of the quadratic function. Using the graph, you can identify the characteristics such as the vertex, axis of symmetry, and some of the behaviors as shown. So we can point to the vertex, right? We could list the vertex. The axis of symmetry is the point that cuts the parabola in half, and that's going to be x is equal to -1. The domain and range, so the input values. Since there are arrows at the ends of both of these, your input values are all real numbers. So your domain is all real numbers. However, your range or output values are going to be limited. This is a solid point, so this -2 is included. So it's all numbers greater than or equal to -2, because it's always going to go, since it opens up, it'll continue to go up and rise that way. To describe the behaviors when x is less than 1, when x, so here's, sorry, -1, x is -1 right here at the axis of symmetry. When it is less, right, when x is decreasing, so if I were, say, from here going out like this, then I can see that y is increasing. So they're opposite. So when x decreases, y increases. Another way to say it, if I'm going to the right, x is increasing and y is decreasing. So here is the, oops, I'm crossing it out. But as y increases as x decreases. Remember, x is our independent and y depends on that. So however you describe x, make sure you're describing y and its behavior based on that. And then for when x is greater than -1, as x is increasing, y is also increasing. So for that matter, I like to always kind of describe it like this. So if I said that when x is less than -1, um, I would put as x increases, y, oops, I guess it's writing behind the picture. How funny is that? Oh, I can move that up, can't I? Can't I move that? Makes it look, yay. All right, there you go. So, these two, make sure that you understand that the behavior is opposite direction, right? As x is increasing, y is decreasing, or if x is decreasing, y is increasing. Makes kind of a huge difference there. Oops, let's erase. Okay, so this is in your book. So we're going to do and describe the characteristics. So we want to describe the vertex, right? Vertex. The vertex is equal to -1, comma 1. The axis of symmetry. So it goes right through the vertex and cuts the parabola into two equal parts. And this is equal to, so the axis of symmetry is where x is equal to -1. All right, what about the domain? Domain is all real numbers. Guess I can move this back down now. We have two L's on real. It's kind of day it is. All right, the range. The range would be equal to all the y values, right? The range is the outputs, and they have to be greater than 1. So y is greater than or equal to 1. Now, when we're looking at the behaviors, um, I would describe it as when x is less than -1, you can say, as x increases, y decreases. Or you could say y increases as x decreases, but know that they're opposites. And when x is greater than -1, as x increases, y also increases. I have a feeling that, I always put X first because that's the way I do it. But I have a feeling that on big ideas, when you're practicing this, they'll probably be describing the Y. So just make sure that you're using for when on this left-hand side here, right? Everything that is less than, if X is decreasing, you're going in that direction. Well, then you can see Y is increasing. So sometimes we'll be describing this first one opposite, but here they're the same on the right-hand side. Okay. Then we're going to be graphing them. So lots of information here. But if you recall from our exponential, we talked about the vertical stretch and the vertical shrink. Okay. So there's a vertical shrink, there's a vertical stretch. All right. So here the blue is our parent function. It's our parent function. And then when a is greater than 1, we talk about this kind of like a scale factor, and it's stretching it, okay? When a is a fraction, it is shrinking it. So I always compare these to like the dilation, because this is a transformation that we do. So when you have a scale factor greater than 1, it's like an enlargement. So in this case, the enlarging it is like pulling it up vertically. Shrinking it is like pulling it down closer to the x-axis. If you have um, a less than 0, so if our leading coefficient of a right there is negative, we have a reflection. So all the same things apply. You still can have your vertical shrink when it's a negative fraction, or you have a vertical stretch when the absolute value is greater than 1. So keep that in mind. So, or they also call that as less than -1 because of the way negative numbers work. Okay, so here is an example from your textbook. We're going to compare them. So the first thing you'll do is make a table of values. And I like to put in about 5 values, just like we did when we did exponential. Kind of gives you a little bit better idea of that curve. Then we'll plot the ordered pairs, and then we'll try to draw a smooth line. But then when we have to compare them to the parent function, in this case, we can see that they both open up, they have the same vertex, but because of this a value of 2 right here, that's going to give us a vertical stretch by a factor of 2 of the original. Okay, so it's a little bit narrower, gives us a vertical stretch. All right, so we are going to go ahead and make a table of values. So we have our x values as our input, right? All real numbers. And g of x is our output. So let's just do -2, -1, 0, 1, and 2. So when we have -2 times -2, right, that's what it means to take x squared, is 4. 4 times 5 is 20. -1 squared is 1 times 5. 0 times anything, so we have 0. And then again, whether it's positive, we have this. So on the x-axis, I'll count by ones, and on the y-axis, I'll count by fives. So starting with my -2, 20, I'll do 5, 10, 15, 20. So I'm just kind of like making this a little bit smaller so it'll fit on the graph. -1 and 5, 0, 0, 1, 5. You can see how symmetric it is, and 2, 20. Um, the drawing of the parabola is the most difficult. All right. Not that bad. Now, if I'm going to compare it to um, my parent function, hopefully, I don't know, if this one is 5, then I have to have 1 down here, right? So there's my parent function kind of going there. You can see that the blue one is kind of pulled up. It's kind of like a stretch. So to describe that, I will say that let's see, they both have a vertex of 0, 0, but g of x, my g of x right here, is a vertical stretch by a factor of 5 of the parent function f of x. So g of x is a vertical stretch by a factor of 5 of f of x. And there's my f of x right here, the parent function without the a term, or a equal to 1. Okay, now we're going to make another table. So we have our input values. In this case, it's n of x. You can also just label them x and y, no big deal. I'm going to work with the numbers a little bit here since I know that my a is a negative fraction. Two things are going to be true. One, it's going to be a shrink instead of a stretch. It's also going to be a reflection. So I'm just going to use some things that are divisible by 10. I'm sorry, divisible by 5. So let me do like maybe -10, -5, 0, 5, and 10. Maybe this will make the math a little bit easier. So we're going to square this. So -10 squared is 100. 100 times a -1/5 is going to be -20. Okay, so it's just taking 100 divided by 5, and it's negative. All right, 5 squared is 25. 25 divided by 5, so -5. This will be 0, -5, and -20. So if I make my x and y, again, I will count by, let's just count by fives on everything. So if I go back, -10 would be here, and then -20, 5, 10, 15, 20, -5, and then -5, and then 0, 0, and then 5, -5, and 10, -20. So you can see the symmetry. All right. It's going to be, oh boy, you guys might have a little better luck, I don't know, on paper, but this is a little tricky. Okay, so first of all, if I'm counting by fives, um, that means that my parent function, ooh, that's way, my parent function would be, like, I don't know, something like that. All right, up here, parent function is right here, x squared. So that's still going to be opening up with the, vertex of 0, 0, but it'll have 1, 1, and negative 1, 1. So you can tell that this one is wider. So when we describe it, we would say that n of x is a vertical shrink and a reflection in x-axis of the parent function or f of x or something like that. So we have a reflection of f of x and a vertical shrink happening because this is wider than our parent function. Of course, if we drew it a little bit better. Okay, hopefully this is making sense as you go. And that concludes the first lesson. So if you have any questions, be sure to let me know.